আমাদের একটু আমি গুছিয়ে নেই। থার্ড লেকচার আজকে, এরপর কি তোমাদের আর কোনো ক্লাস আছে?
জি স্যার, 11টার সময় আছে স্যার।
আচ্ছা ঠিক আছে, তাহলে আমি শুরু করে দেই, দেরি না করি। আর কালকে দুইটা, তাই তো? ঠিক আছে। ম্যাডাম ক্লাস নেওয়া শুরু করছে?
না স্যার, উনি এখনো ক্লাস নেওয়া শুরু করেননি।
ঠিক আছে, তাহলে একটা দুইটা এক্সট্রা স্লট রাখো, যে কোনো সময় আমারও লাগতে পারে। লেকচার 1, লেকচার 2, ওকে। Okay. Let's start from the last class. In this lecture, today we will start the details of rock. So the rock can be defined as a consolidated or poorly consolidated aggregate for one or more minerals and organic matters. That means in rock it's composed with more than one, maximum case more than one composite minerals. And at the end of this lecture, that means that end of the discussion of rocks, we will discuss the details about different rock forming minerals, the principal rock forming minerals, their properties. Those are most readily available in the different rocks like igneous rock, sedimentary rock, or metamorphic rock. So these are the three different types of rock. The first one is the igneous rock, second one is the sedimentary rock, and the third one is the metamorphic rock. So let's first start with the igneous rock. The igneous rocks, these are the formed by the cool solidification of molten magma. That means at the core of the earth. So if we consider this on earth, and suppose these are the core segments, some portion, the core, and when we move towards the surface, this is the outer crust. So at the deep core of the earth, there are very high temperature, and at this high temperature, this magma are in the liquid form. So when it comes out with the volcanic eruption or some other ways, so these magmas are solidifies due to the rapid decrease of temperature, and then it solidifies in the surface of the volcano from, and in this case these are the called lava. So when this lava cools, and due to the very quick cooling process, sometimes there is no crystal is formed. That means you will not find any crystal structure of the minerals in the igneous rocks, and the rocks sometimes look like shiny or glass like. It depends on the mode of formation. Later we will discuss the different mode of formation of uh, igneous rock. So, and sometimes as the inner crust of the earth contains various gases, so when it solidifies to the temperature, during temperature decreasing, sometimes bubbles are trapped in the liquid magma. This maybe sometimes can be discussed like dough type materials. So gas bubbles are trapped, and due to the gas bubble are trapped in the so liquid portions, when it solidifies, it creates some void in the solid rock. So like some tiny holes or spaces in the rocks, and these types of rocks you may find in one of these example is the uh, light piece aggregate or lightweight aggregate. These aggregates are basically not found in our country, but these are imported by some Zane's company or garments factories. Those are used for washing the denim clothes. Like you may find in some garments factory, they are use these types of rock to wash the denim. Sometimes you are using today's different types of denims, those contains fade color. Okay, this so these types of washings are actually done by rubbing this light piece of rocks in the denim cloth. So this is an example and use of such types of light piece aggregate. And nowadays these aggregates are also used in the construction as well. So later we will discuss, or we may show if possible some typical examples. So the next one is the sedimentary rock. The sedimentary rocks, these are the formed from eroded fragments of other rocks, or even from the remains of the plant and animals. So the sedimentary, from the name it can be easily identified that the sedimentary rock is formed by some sedimentation deposition process, like lake, ocean, or desert areas. And when these materials are, suppose this is a hill and this may be a valley. So when the materials are due to the landslide or rainfall or any other natural process, some sediments along with plants, animals, or any other due to some natural disasters, those may entrapped in this position. So while these materials are deposited, and after many years, due to some geological process and cementation process, after a long period, this portion may be found as a rock. And based on the nature of the rocks, the sedimentary rocks are different categories. Like when it's creates from the sand, it's called the sandstone. Okay. And when the mud are trapped in a positions, and after solidifications, it called the mud stone. And the seashells are formed in the rock, it's called the limestone. So due to sometimes fossils, like the plant, animals, etc., those are also frequently found inside the sedimentary rocks at different layers. Those are the called strata. Okay, and the last example of a rock for me is the metamorphic rock. So these metamorphic rocks are actually the transformed version of a sedimentary rock or the igneous rock that have been transformed by pressure, some external agents like the pressure, heat, and the intrusion of fluid. So these are the basic reasons for the formation of the metamorphic rocks. The heat, those maybe come from the nearby magma or hot water intruded. This metamorphism is actually done inside the earth crust. So this may be come from the nearby magma or hot water intrusion by a hot from some hot spring, or sometimes it can be due to some tectonic movement. That means later while we discuss the earthquake propagation, we will show how the tectonic plates are moved towards from one another, one towards another with respect to relative position. So in those steps, due to the movement of the tectonic plates, that means suppose this like this, these are the fault line. So while one move another, or relative movement, that means one plate forced against another one, that means a huge pressure is induced during earthquake. So this pressure actually causes one of the catastrophe of the metamorphic rocks beneath the earth's surface. That means these tectonic forces like draws the rocks beneath the earth's surface. Okay. So this is the another example. That means the limestone, it is a sedimentary rock, and due to the metamorphism process, this creates marble. And quartzite, this is another example of the metamorphic rock. Those are actually metamorphosed from the sandstone. That means these are the natural processes. So at the initial steps we discuss three different types of principal rocks, that means the igneous rock, sedimentary rock, and the metamorphic rocks. Let's have discussed with some the physical properties of the rocks. That means first one is the strength, then toughness, abrasion resistance, etc. There may also some other important properties like the density, absorption, porosity, permeability, heat resistance, and durability. So strength are generally defined as the compressive strength. That means the strength of rock means the its compressive strength, while most of the rocks are weak in tension, like the rock are the actually concrete like materials, so they have no weak in tension. For example, the granite rock, so here it is noted that its compressive strength is 5000 to 60000 psi, while the tensile strength is very low. So these are the in general the strength of rock means its compressive strengths, and the measuring how to measure, calculate the compressive strength, this is very easy in civil engineering practice. We rarely conduct these tests, or in our petroleum and mining engineering department they also conduct such types of they have laboratory to test the rocks. In the compression machine, that means we apply the compressive force on a certain shapes of rocks, and then we calculate its the compressive strength. So this is one property. And next one is the toughness. The toughness is the resistance of the rock to impact at the defined toughness. Actually these are some laboratory tests by which we can um, by which we can define its various parameters. So toughness means the impact for capacity to resist the impact force. This property is particularly important when the rocks are subjected to severed, used, and impact. And next one is the abrasion resistance. This is the sometimes desirable to determine the resistance of the rock. Those are subjected to abrasions. This abrasive hardness Ha. So here is an empirical equation to calculate the abrasion resistance. And some other important properties. The first one is the density. The density calculation is very easy. Suppose it's if you take a solid rock, so if you take its weight and its volume by some volume displacement method, or if it is in a regular shape, you can simply calculate the volume by taking its dimension. Suppose it is a cubic shape, so if you measure all its dimensions, and if it is apparently cubic shape, you can simply multiply all the dimensions to get the volume. Or if it is in the irregular shapes, so for irregular shape elements, we can calculate the volume by submerging it in water. That means water displacement method. By using water displacement method, you can find the dense volume, and then if you take the its weight, then it will mass by volume, you will get the density. So the density is another parameter. So based on the density, you can take decision that okay, these rocks is very dense. That means it maybe sometimes basically metamorphic rock and igneous rock may have higher density compared to the sedimentary rocks. And it also depends on its degree of pressure, temperature, etc. So here you can get an idea about the rocks. And then next one is the absorptions, porosity, permeability. These are the very close relative terms. The term porosity means the now amount of pore or void in the rock. That means as the number of if the density is low, that means there may be chance of greater porosity in those rocks. And if the porosity is higher, successively the absorption will also, or that means the water absorptions, these will also be higher. And the permeability sometimes there are two conditions. So one is the water permeability, and another one is the gas permeability. So this permeability actually denotes that how many fluid or gas can pass through the rock at certain times. That means under certain hydraulic gradient or pressure, or how many gases or liquids can pass through it. So this is indirectly related with the porosity. The greater will be the pore in the rock, the absorption as well as the permeability, those will be higher. The next one is the heat resistance. Heat resistance is actually nothing but the insulation property. That means, as I mentioned earlier, the light piece aggregate, those aggregates are very light and having higher void. So this will transmit less heat. That means if you use this rock in the construction or any other process, you will get a heat resistive element. So this is another. And the last one is the durability. That means it's durability when it will exposed in the nature or some corrosive environment. So this is its indication. Now come to another topic. This is the rock cycle. So we discuss three types of rock: igneous rock, sedimentary rock, and metamorphic rock. So here there is a cyclic relationship, or there is a interrelation between these three rocks. So now we will discuss how these rocks are transformed. It's in a sequential event on which one rock is transformed to another one, or altered, destroyed, and reformed. So these are the process, and then it's a result of internal and external. Due to the internal and external earth process or geological processes, these rocks are interchanged to one another. So at very first, let's start with the molten magma. That means igneous rock. When this magma, this red portion is the molten portion. These magmas are comes outside through some pore or void like these paths. When these are comes through uh, some void, so suppose if it comes some volcanic eruption, it comes outward. Okay. So and or sometimes there may be not possible, not some active volcano. So in those cases, these magmas are actually comes and solidifies in some step like this. uh, some positions in the beneath the earth surface. So or sometimes it may become out the earth surface. So if this molten magma comes above the earth surface and gets solidifies, the we will call this the igneous rock. Okay, igneous rock. And this will be extrusive in igneous rock. And if it solidifies inside the earth surface, uh, earth crust, we will denote it as the intrusive igneous rock. So these are the basic two types of igneous rock. Later we will discuss many other types based on their shape, mode of formation, etc. So mainly two types: the extrusive and intrusive. The extrusive igneous rock, those comes solidifies above the earth surface, and if it trapped somewhere beneath the earth surface and gets solidified, forms the rock, we will call it the intrusive igneous rock. Both are mainly comes from magma. Okay. Next, after when this igneous rock may be exposed, sometimes extrusive, suppose intrusive igneous rock. So this is formed beneath your earth surface, but due to some geological process like weathering or uplifting or exposure, sometimes due to the earthquake. Okay, due to earthquake, sometimes tectonic plates moves one another, and some in some cases this due to tectonic plate movement, some portion of the earth surface or the rocks, those are beneath the earth surface, comes or exposed to environment. This is one process by uplifting or exposure by tectonic movement. Or due to weathering, suppose it forms 6 feet or 10 feet below the earth surface, but due to passage of hundreds or thousands of years, the wind or river, due to the flow of river, suppose if it was the underneath a river. So due to the movement and erosion of river, in some cases this rock may be exposed to direct environment. So these are the effect of weathering. Due to weathering effect, some intrusive rock may exposed, or extrusive igneous rock, these may also due to weathering process. This may also weathering, and then next one is the transportation. That means due to weathering process, these rocks can be fragmented into small pieces. That means erosion may occur due to the fragmentation or fracture of the rocks. These small portions may transport and deposit. That means suppose sand, so it can, in desert area the sand is readily moved from one place to another place due to wind, or if it is a river or ocean bed, or current, or for a hilly area. So this due to the movement of water or spring. These fragment small portions may transported a long distance, and at some points where it is a valley or trap, in that positions it can get deposit. So due to deposition, and it may deposit, and after deposition and sedimentation, that means after deposition these are get condensed in a sediment like materials, and thereafter a process, this is called the lithification. Later we will discuss details about the lithification. Lithification is a complex process of the uh, cementation, compaction and cementation. That means in lithification process, these sediments get compressed due to some natural pressure, or some geological processes, and some natural cementing agent. Sometimes nature also have some cementing agents. So with the combined effect of this cementation and the compaction, that means compressed consolidation, this lithification process yields to sedimentary rocks. That means these loose sediments come, this loose sediment turned into a sedimentary rock. Again, this sedimentary rock may be again exposed by uplift or exposure. This sedimentary, from this stage, this sedimentary rock may again exposed, or it may go for exposure, or may for metamorphism. Suppose if it goes for exposure, sometimes rock is sedimentary rock is formed again after 100 years or 200 years, due to some abrupt change in the geology, or due to some tectonic causes. This sedimentary rock may again exposed to the weather, and same loop may occur. Okay, so this is one way, and another way, this sedimentary rock may be go further beneath the earth surface. That means it may move towards the earth crust due to geological process, or due to tectonic causes, and again, so it may enter to the next process. This is the metamorphism. So this metamorphism is actually is another process by which the metamorphic rock is created. In metamorphism, there are some process or some elements of metamorphism. Those are the heat, external internal heat, temperature, or fluid intrusion. These are the combinedly known as the metamorphism. By this metamorphism, this metamorphic rock is created. Again, if this metamorphic rock may exposed to weather, and same process, same loop, it may follow the same loop. Okay, it may follow the same loop, or this metamorphic rock may move towards the center of the earth. So if it moves or center of the move, so the center of the earth, as the temperature is very high in the center, this zone. So this metamorphic rock may, due to the melting of at high temperature, this metamorphic rock may again become liquid magma, and the same process may repeat and repeat sometimes. So this is a complex cycle. It's a complete cycle of the rock formation. That means formation, alteration, distortion, and reformation of this rock from igneous, metamorphic, and sedimentary. So this is an cycle of rock formation. So this cycle is known as the rock cycle. So here is an interrelation between these three rocks. So let's start with the igneous rock. Igneous rock may have different types. The first two types we discussed already based on the solid position of the solidification process. That means the location at which it solidifies. If the magma solidifies below the surface of the earth, so we will call it as a intrusive igneous rock. And if it forms on above the upper earth surface through some volcano, then we will call it the extrusive igneous rock. Again, here are some other types: batholites, dikes, sills. Okay, so while it moves from the earth crust to the outer surface, if it trapped, as you know, many our earth surface and earth crust is not solid at all. Okay, in some positions there may have some void. Suppose we get some minerals or gases, or sometimes even water. We extract water from our ground, so there may have some void at where the gases or the minerals are trapped. So like this, there may have many voids in the uh, earth crust or upper crust, while this molten magma moves upward due to the internal pressure. So suppose it's moving to upwards. If it have a void in this area, so very close to this pipe, feeder pipe, that means this piping path. So if it is very close, there have a chance to create a channel, and say magma passed through this area and form a Yes, it can be filled by this liquid magma or this void, and then after solidification and cooling process, okay, you will get here a rock, intrusive igneous rock. So there are many types of intrusive igneous rock based on their shape. This is geologists are classified based on their shape, formation, types of formation, etc. So batholites, those are the large bulb-shaped intrusive igneous rock. Roughly, those are the commonly in 5 to 50 mm. If the diameter is 5 to 50 mm in diameter, its property only. So these will be called the batholites. Are mostly most a common example is the granite. Okay. The next one is the dikes. So these are the smaller sheet type igneous rocks. Suppose look at this portion. These have a dike. Um, so if as you may know later, while we will attend the classes of folded bed, fault joint, and folding bed. That means our earth crust or upper crust is composed of many layer, single layer. That means layer 1, layer 2, layer 3, having different thickness. So while sometimes between two layer of earth surface have some void. So when it move, there is small sheet types between these two small void. When it intruded and gets solidifies, it's called dikes. Mostly 1 to 15 kilometer wide, but this layer is very thick. And the shields are actually also similar to sheet type intrusion, but these are the parallel to the bedding. That means suppose this is a bed or country rock, and shields are the parallel. When it's parallel to the bedrock, so it's called the shields. Here is the some summary of some main minerals of igneous rocks. The first one is the quartz, feldspar, muscovite, biotite, and mafic. Okay, so this table represents its chemical composition, color, hardness, density, and common morphology and its feature. So you may read details about this rock forming minerals. And next, here is some visual image of those. So first one is for quartz, next one is feldspar, then muscovite, mafic, biotite, etc. So, first one is quartz. This is very known to all of you. This is mostly found in Sylhet or different regions. This is the actually white. This is our white stone. This is also found in nature. You may also see in some hilly areas. Some like those hills are composed of rock, rocky hills. If you go there, you will find such types of rocks, and if you inspect, you will get such color or something else. Then you can easily decide, okay, this is the quartz based igneous rocks, or this is the feldspar, etc. So this is another classification of igneous rocks: a plutonic rock, hyperbasal rock, and volcanic rock. This classification is based on the depth. Okay, based on the depth, that means at which the magmas are cools and solidifies. The igneous rocks are distinguished in plutonic rock, hy- hyperbasal rock, and volcanic rock. These three types are based on the position, that means at which depths. Suppose so here, so these are from earth center to upper layer. So this moves a long distance, and this magma may solidifies at different points. Suppose these dikes may occur in this position, or it may occur in this position. So or depends on the depth, this classification is done. When the magmatic materials cools and solidifies at very greater depth, so it will be called the plutonic, first one. And the resulting rocks will be called the plutonic rocks, like granite. That means it's in the greater depth. And one of the properties of the plutonic rocks is that the rocks will be in the coarse grain. That means the grain size of the rock will be larger. And next one is the hyperbasal. These rocks are the solidifies at the moderate depth. That means an intermediate depth from the center to outer crust. That means if it solidifies in the intermediate depth, like dolerite. So these rocks are will be the medium grained. Okay, this hypobasal rocks will be in the medium grain size. And the volcanic rocks, when these magmatic materials those cools and solidifies over the ground surface, that means the all types of organic extrusive igneous rocks, those are the classified as the volcanic rocks. These will have the very fine grain or glassy in nature. So these are the volcanic rocks. This is based on the depth. Okay. So next we will discuss some forms of igneous rocks. These forms will actually based on the shape or other positions, like the concordant bodies. First two distinctions of form based on the form of igneous rocks. First one is the concordant bodies, and second one is the discordant bodies. So let's start with the concordant body. The concordant bodies are actually those when the magmatic materials is guided by the bedding plates of the surrounding rocks. That means uh, there are many thick sheet of our earth crust. So when these magmatic materials are guided by bedding, we actually already discussed someone like seals already discussed. So this is then repeated one with some figure. So these resulting igneous bodies are called the concordant bodies. These bodies occurs in the following few terms. So let's discuss with some figure. First one is the shields. Shields is the materials penetrate along the bedding plane and may solidify, resulting form of the flat sheet like bodies called shields. That means uh, suppose this one is one, and bed, and this one is another bed, two bed, and along these two bedding surface face, and here is a void. So when these magmatic materials come in this path, it will penetrate through this point. So this is a sheet type rock will form along the parallel to the bedding bed. So this will be called shills. And next one is the laccolith. Laccolith are the barn-shaped bodies, those formed by the accumulation and solidification of magmatic materials of higher viscosity along the bedding planes. That means sometimes when you conduct the classes, actually the madam will conduct those portions, the synclined, anticlined, and synclastic shell, anticlastic shell, like this, a synclined, anticlined, and folding bed. So in those lectures, you may find all the beds are actually not in parallel to one another. Sometimes you may find such type of plane. So this is an the straight plane, and this is another bed. This is moving upward shape. So in these types, here is a void. Okay, here may have a void. And when magmatic materials or molten lava come to this path and trapped in these types of position, it will create a barn shape rock. Okay, the shape is barn type shape. So these are the called laccolith. Okay, and next one is the pacholith. Pacholith, these are the magma, when the magmatic materials penetrate the folding rocks may accumulate along the crest and trot. That means this is crest, this is trot. Two conditions may occur. So both are the band, and due, along these two band, here is a small gap. Okay, again along these two bed, uh, as those two beds are not parallel to each other, so there may have gap. So when the magmatic materials trapped in such gap, the and form some lens shaped bodies. That means the shape is lens type. Okay, like this, not so, or maybe like this, these lens shaped bodies. So these will be called pacholith.
স্যার হ্যালো স্যার ম্যাগমা ম্যাটেরিয়ালটা কি অবস্থায় থাকে মানে সলিডিফাইড অবস্থায় নাকি
Liquid. Actually the earth crust have very high temperature. So the crust, the inner surface, or the earth center have the liquid magma. When it's come towards the outer surface, or it moves, it getting cool down. Let's later we'll discuss how it cool downs and the rate of cooling and many other factors may emphasize. So we will later discuss this. Next one is the lopolith. So lopolith, this is the large scale intrusion of basic magmatic materials may result the formation of centrally sunken saucer shaped bodies. The body will be like this. It's a very long. There may have a roof rock. Okay, may have roof rock, and this is the bedding rock. Along these two rocks, here is a large gap. Okay, like pan shape, sunken pan shape, like this pan shape void. So when these magma are trapped in this position, these will be called lopolith. Okay, so these are actually some different types of concordant bodies. That means all of those are types of intrusive igneous rock. And next one is the discordant bodies. I have already shown some discordant bodies like batholites. These are already discussed. Dikes, this is already discussed. So these are the some discordant bodies. When the magmatic materials cut across the bedding plane, or the surrounding of the surrounding rocks. These resulting igneous rocks bodies are called on the discordant bodies. That means all the concordant bodies we discussed already. These are actually the magma trapped between two layer or between two bedrock. Okay, between two bedrock, if they have different shape, void having different shape. So when the liquid magma trapped in those voids, it takes the shape of exactly takes the shape of those voids. So these are the concordant bodies, and sometimes this magma cross across the bed. That means when it moves upward, it cross different layers, and then it forms the discordant bodies. First one is dike, then ring dike, cone sheets, volcanic necks, and batholites. So first one is the dike. Dikes are the magmatic materials cutting across the bedding planes or surrounding. These are the called dikes. So these are when these channels sometimes may solidifies. So these are the vertical rocks. These are the dikes. Ring dikes. The magmatic materials may fill cylindrical cracks in the rocks. That means these are the dikes, but this is not actually not possible to show in the 2D picture. So it may form in cylindrical form. That means ring shape. If we cross take a cross section, you will show it may formed in a ring shape. That means in the vertical something hollow pipe shape or ring shape in the vertical along the vertical plane. So these are the called ring dikes. Cone sheets, when the magmatic materials accumulate along the cone-shaped fracture. That means it may forms in a conical shape. That means the opening. Actually, these all of these will be based on the shape of opening or the shape of voids along the vertical surface. So if the shape is like cone shapes, it will create some more like the cone sheets. Okay, the volcanic necks and batholites. Batholites is already large shaped igneous rocks. So these are the already discussed. The magmatic materials when it solidifies along the vents of the ancient volcano. Another is a volcanic neck. Volcanic neck means suppose if even passive volcanoes, those are those are active many years ago. So the magmatic materials may solidify along the opening of those volcanoes and remain as the neck like bodies over the ground surface. So these are the volcanic necks. That means suppose so this is a volcano. This was active many years ago. When after one single eruption, it may get solidifies. That means here and when it solidifies along this path, so you will get a neck type rocks. This will be called the volcanic necks. Okay. So in next class, hopefully we will discuss the mode of formation. That means how the igneous rocks are formed, and their properties may also depends on the mode of formation, their viscosity, their density, based on the viscosity, temperature, etc. And based on all these, the mode of formation and the agents of mode of formations, the properties of rocks will vary readily, like the density, porosity, grain size, etc. All these parameters will um, varies depends on the mode of formation. So up to this, some types of igneous rocks. So if you have any question, the floor is now open regarding this lecture. Okay, bolo. হুম। হ্যাঁ, আরেকটা হচ্ছে বেডিং প্লেনের কোনো কাট করে না, দুইটা বেড, যেটা বেডরক আছে, বেডরক গুলোর মাঝখানে ভয়েড থাকে। সো ভয়েডের ভিতরে যদি হ্যাঁ এনট্র্যাপড হয়, তখন সেটাই হচ্ছে কনকর্ডেন্ট বডিজ। হ্যাঁ, শেপের উপর ডিপেন্ড করে আসলে নামকরণগুলো করা হয়, আর ডিফারেন্ট শেপ হয়, ওই শেপের উপরে এই হয়, আর কিছু না। এগুলো আমরা নেক্সট ক্লাসে ডিসকাস করব। মোড অফ ফরমেশনটা আসলে অ্যাকচুয়ালি ডিপেন্ড করে, মানে ধরো তোমার যে কুলিং হচ্ছে কত মানে কত কুইকলি কুল হচ্ছে বা টাইম নিচ্ছে, হ্যাঁ এটা একটা ফ্যাক্টর। তারপরে হচ্ছে কোন পজিশনে হচ্ছে, দ্যাট মিনস কুলিং হওয়ার সময় কিরকম প্রেসার থাকে সারাউন্ডিংস, হ্যাঁ এগুলোর উপর ডিপেন্ড করে, বা কি টাইপসের তোমার ম্যাগমা আসতেছে সেটার মলিকুলার কনসেন্ট্রেশনের উপরে, এইগুলো প্যারামিটারের উপর ডিপেন্ড করে অ্যাকচুয়ালি রকের প্রপার্টিটা ডিফাইন হয়। ধরো কুইকলি কুল হলে হয়তো বা ক্রিস্টাল হবে না, বাট স্লোলি যখন কুল হবে তখন ক্রিস্টাল ফর্ম হবে। এরকম আরো অনেকগুলা ফ্যাক্টর থাকে, তো এই সবগুলা মিলে হচ্ছে তোমার রক্সের প্রপার্টিগুলা ইয়ে হবে। এটা আমরা নেক্সট ক্লাসে মোড অফ ফরমেশন গুলা ডিসকাস করব। দেন হচ্ছে কি কি হয়, ম্যাগমাটিক ডিফারেন্সিয়েশন একটা অপশন আছে, একটা টপিক আছে। তো ম্যাগমাটিক ডিফারেন্সিয়েশন কেন হয়, এগুলো আমরা নেক্সট ক্লাসে ডিসকাস করব, এবং এটার উপরে রকের প্রপার্টিগুলো বেসিক্যালি ডিপেন্ড করবে। সো ঠিক আছে, নেক্সট ক্লাস কালকে তো আমার সাথে না, 10টা থেকে?
জি স্যার।
আচ্ছা, তাহলে 10টা থেকে 12টা পর্যন্ত 2টা ক্লাস হবে।